Welcome back to another one in our series on visual patterns. This is visualpatterns.org, puzzle number 406. It is a very interesting puzzle. It is also pretty high level because it goes into a lot of really interesting and cool patterns. So let's begin the way we normally do and recognize now vertically I have the X's, step 1, step 2, and step 3. And then for each step, the output, the Y value, I can begin by just counting. So in this first step, I see 4 and 4. I see 8 total purple squares. In the second iteration, I see there's still like this 4 and 4 from the beginning, but then there's 5 and 5 in the middle. So now I got 9 plus 9, that's 18. So iteration 2, there are 18 purple squares. And then iteration 3, I can see the 18 still because there's this part and there's this part. But then in the middle now, there's 2 rows of 1, 2, 3, 4, 5, 6, 7. So 7 plus 7 is 14. So 18 plus 14 is 20 plus 12 is 32. Now for the fourth iteration, it gets pretty complicated to just draw it, but maybe not really, because this is where your student should have many ways to see it. I've been looking at how it's like a step pattern. 1, 3, here it's 1, 3, 5, here it's 1, 3, 5, and then 7. And then, so I can assume it's going to keep going. 1, 3, 5, 7, and then 9. And it's the same on the bottom, but in reverse. So if I add all these up, 9, this part's 9, plus 9 is 18, plus 7 is 25, down here is 25 more. So in the puzzle here, it would be 50. Now, your students are going to look at these numbers, hopefully thinking carefully, what's going on here? Well, like up in this set, I have 4 and 4. And then here, the 18 is built out of 9 and 9. And then down here, when I break this into 2 parts, it was 9 plus 7 is 16. And 16, that's where my 32 came from. Well, if your students haven't come up with this yet, what kind of numbers are 4, 9, 16, and 25? They're perfect square numbers. That does help us build the equation. So we can see that really it's like this is 2 squared, but then there's 2 of them. So it's 2 squared times 2. And then here it's 3 squared times 2. And then here it's 4 squared times 2, and so on. Okay, so our next task is to try to actually write an equation or an expression that gets us this output given any input. So this is where we look at the step number compared to the numbers in the expression. Here at step 1, we have 2 times 2 squared. Here in step 2, we still have 2 of the same image, but then it's 3 squared, and here it's 2 and 4 squared. Well, how are these numbers, 2, 3, and 4, related to the step number? That seems important to me. Let's try this out. So we could try 2 times, well, 2 is 1 more than 1, 2 times x plus 1 squared. That seems to make sense to me. Let's plug in these x values and check. If I plug in step 2, 2 plus 1 is 3, 3 squared is 9, times 2 is 18. Even over here for step 4, 4 plus 1 is 5, 5 squared is 25, times 2 is 50. So I could plug in 10, 10 plus 1 is 11, 11 squared is 121, and then that doubled is 242. Now we know when it's a linear equation, we can check the differences from the steps and they will be equal. But in this case, it's a growing difference because it's an exponential growth. So 8 to 18 is a change of 10. 18 to 32 is a change of 14. Then it's a change of 18. But if you look, the second difference here is 4 and 4. Now that is proof that it is a quadratic function. It's also proof that 4 is part of the expression, but we don't see it that way yet. But we could if we expanded x plus 1 squared times 2. So there's other ways to see this as well. But first I'm going to do the math part. X plus 1 times x plus 1. I'm going to expand x plus 1 squared. So I just know I multiply every part by every other part within these two factors. X times x is x squared. X times 1 is 1x. Here, 1 times x is still 1x, and 1 times 1 is 1. So I can simplify by combining these two x's, and I get x squared plus 2x plus 1. But remember, all that's being multiplied by 2. So now I multiply this expression by 2, and I get 2x squared plus 4x plus 2. And I promised you that this 4 is part of the equation or expression. Interestingly enough, it shows up right here, the same place it would show up if it was a linear equation with the slope of 4. So it's still sort of very much related. Okay, so now I've got my entire equation. Y definitely equals 2x squared plus 4x plus 2. And here it is in graph form. It's going to be a parabola. But let's see if we can pick out the way this looks based on these equations. You're going to want to ask your students to really think about where these equations show up. I'm going to begin with this bottom one, even though we know these equations are all equivalent, because I want to have my students look for two groups of x squareds. And so here, like in step 3, that will be a 3 by 3 square. So here we have one that's 3 by 3, and then another 3 by 3 square. That's literally 2 sets of x squareds. Then let's look for 4 groups of x, which in this case is 3. I need 4 groups of 3. Here's one group of 3. Here's another group of 3. Here's a third group of 3. And a fourth group of 3. That's the 4x. And then plus 2. I can see that here's 1 and 2 leftover squares. So that fits. But let's see if it also works up here. Let's look for 2 groups of x squareds. That's going to be 2 by 2. And then I need 4 groups of x, so 4 groups of 2. Here's one group of 2. Here's 2 groups of 2, 3 groups of 2, 4 groups of 2, and finally the 1 and the 2. So it does seem to be working out. And I could then draw iteration 4 and even iteration 10. So in here could go any of these 3 expressions, really, because these are all equivalent. Have fun with this. This is a real challenge. Please like and follow, and recognize I have a whole bunch more of these videos on my YouTube channel. So please like and follow for more. Have a great day. Thanks.